So this is 4.2. It's got two techniques you learn, vertex, intercept form, and I actually went over those yesterday. Yep, over your formulas. The graph of a quadratic in vertex form, it's actually given down here. But it's y equals sum a, parentheses, x minus h squared, because squaring is what makes us a quadratic. Squaring is what gives you the parabola shape, kids. Plus k. Now, if you've had a pulse the last month and a half, you ought to know what h and k give you. What do they give you? They give you the vertex. Give you the vertex. A is scale factor. And there is a way to treat it like slope, but I don't want to teach it because I've done it in the past and kids murder it to death. So I'm not going to.
What do you mean murder it to death?
Well,
They don't know what to do.
it's what you can do one block to the right or left. It is slope in the initial blocks to the immediate left or right. That's what it is.
Oh, so
But it doesn't extend past that. Yeah. And it gets really funny when there's fractions. So I don't teach it. But it's only about the first block. Past that, it has no bearing whatsoever. So I don't even teach it using that. We just use points. So here's one given to us. It is in vertex form. Y equals negative 1/2 of x plus 2 squared plus 5. So we pick out the vertex. Thank you, Sam. Negative 2, 5. If something is in prison, do you believe it? No. You always change the sign. Change. Keep. It's that simple. And for all of math, anytime you exit parentheses, brackets, square roots, whatever, you change sign. It's not something that ever goes away. That stays constant. This is always done. You leave jail, you change your sign, kids. Always happens. Your vertex is at negative 2, 5. So back to rise 5. And I like to plot things as I find them. There's your vertex. You remember what passes through a vertex? The axis of symmetry always passes through the vertex. It is smack dab the middle of the graph. It's the most important point. X equals negative 2. It's literally that point right there. That literally says x is negative 2. That's what it is. We're going to go after the y-intercept because the vertex just gives us a vertex. That's all it gives us. Vertex form gives you vertex. You go after a y-intercept. How do you get a y-intercept? Let x be 0. Okay, so negative 1/2 of a 0 plus 2 squared plus 5. 2 squared is 4. What's a negative half of 4?
Negative 2.
Negative 2 plus 5 is 3. Grant, I don't know what you're doing. How'd you get 9?
It's 4 plus 5. It's squared. 4. It's 4 plus 5.
What's in front of the 4?
Did you multiply it first?
You have to. PEMDAS. You have to do the multiplication before you do the addition. You understand how we got that, Grant? Okay. So the y-intercept's at 3. Now, if I have a y-intercept, I have enough to finish the graph. This point is 2 to the right of the line of symmetry. I go 2 to the left. That's all you need. You only need 3 points. The other point happens back here at negative 4, 3 by symmetry. It is. It's always easy if there's a y-intercept. Oh, by the way, I added 2 things to your quiz Friday. One of them was, how do you find a y-intercept? Let x be 0. And the other one was, how do you find an x-intercept? Oh yeah, you guys know what you're doing, but guess what? There'll be a lot of kids who miss it because you shouldn't be in Algebra 2 because you haven't tried in a long time. It's just memorization, kids. You want to know how I'm good at this? I memorize multiplication tables. Don't know how I'm good at this? I remembered what 2 plus 2 was. You know I'm good at this? I remembered a bunch of formulas. I didn't do anything special except I remembered stuff. That's all there is to it. How do I know how to solve problems? Because I solved problems like that in the past. I remembered how to do it. What you got? Domain, what's the domain? Yeah, because they all are, aren't they? Now, I know full well there's a lot of kids who don't understand that. So does anybody want to ask Sean that? Because apparently I don't know how to explain it to you. Small number first, big number last. That's all there is to this stuff. Small first, big last. That's really all there is to it. If you can't be it, you use parentheses. If you can be it, you use a bracket.
So the 5 will always do
When you're talking range, the small number is negative infinity because this thing falls forever. The high number is 5 because that's the highest y value. Small number, big number.
But if it would be a positive, it would be like 5.
5 to infinity. Yep.
One more question.
Yes, sir.
What would it be just a normal parenthesis on the 5?
There was an open hole. You'll see stuff like that, but not on parabolas. If there was an open hole there, just like on a number line, then we would do it. Those are solid dots, and you can have open holes on graphs. All right, we got another one. It's going to work about the same. So we're looking at example 2, and in example 2, Chandler, can you tell me the vertex?
4 and negative 1.
4, negative 4. He changed his sign and he kept his sign. That's all you do. Change sign, keep sign. So the right 4 and fall 4. Axis of symmetry is literally the x value of the vertex. X equals 4. That's all there is to it. Wade, how do we get the y-intercept?
Let x be 0.
Let x be 0. Let x be 0. Kids, plug it in, crank it out. 1/2. 0 minus a 4 squared minus a 4. What is 0 minus 4? What's negative 4 squared?
16.
What's half of that?
8.
And 8 minus 4 is?
4.
No, we ain't doing anything complex here. I swear we're not. So the y-intercept happens at 4. Now, this is what I did so far. I guarantee you there are about 4 of you in here thinking that I would draw a parabola like this.
You might go to the other side.
This is the vertex.
Yeah, so you're going to do it on the other side.
That's why I said it's important to label your vertex. Because if this is what I saw, and I know me well, I would draw the wrong thing. It's very important once you find the vertex to label it, or you will make a mistake. I don't care how smart you are, I don't care how dumb you are. You're going to make a mistake if you don't label it. That's one of the reasons why we also draw through this line of symmetry, because it makes it easier to count when that's there. It makes it far easier to count. These little things that take a second of our life make things easier. They do. Now that other point we found, that y-intercept, is how many units left of the line of symmetry. So where's the other point? It's 4 to the right. which Ty is right. It's at 8.4. And now it's going to look right. So get in the habit of labeling your vertex, get in the habit of drawing in that line of symmetry, and it won't be hard to do. Then you need domain and range. A infinity. Trey wants the range. Go ahead, Trey. You got volunteered. What's the range?
-4, positive infinity.
All right. Tell me about the parentheses and brackets.
The bracket would be first and parentheses would be behind that.
Good job, Trey. Spencer, Trey can do it. Can you? All right. Write the given function in vertex form. These guys are in standard form. They are literally written ax squared plus bx plus c, even though there might be a plus or minus sign. They are in standard form. Now, what you should do is you should go ahead and pick out a, b, and c. A is 1 because that's in front of x squared. B is 4. C is -6 because we need those letters. We need those letters. I mean, even vertex form starts off with what letter? It starts off with an A, doesn't it? That's where this comes from. We need that number. We do. I'm actually going to, so we talked about it there. I actually want to do this one, the one down below, because it's a little bit harder. So let's do A, B, and C again. What's A? 2. What's B? What's C? 6. So this is what we're going to do. I've got the steps off to the side. The steps off to the side are to find the coordinates of the vertex. You have a formula for that. How do you find the x coordinate of the vertex? X is opposite b over twice a. And I keep writing this down. I keep writing it down. That's why I know what it is, kids. Okay? So if you're one of those kids who just watches and takes minimal notes, you're not writing stuff like this down, of course you can't remember it. Of course you can't. You're doing bare minimum. So opposite of a -4 is 4. A was 2. Twice a 2 is 4 as well. What's this end up being? 1. There's the x coordinate of the vertex. How do we get the y coordinate? Plug it in. Twice a 1 squared minus 4 ones. And you can use a storage feature on the calculator, but this one's pretty simple. 1 squared is 1. Twice that's 2. Minus 4 is -2. Add 6. Where are you at? There are 4. There are 4. So here's what you found. You found that your vertex was the ordered pair what? 1, 4. Alphabetical order, Dylan. X, Y.
So it'll be 2 parentheses x minus 1 plus 4.
That is correct. We are going to plug everything that we have into a times x minus h squared plus k. The vertex gives you the letters h and k. And you talked about what a was earlier, didn't you? It was 2. So our equation is y equals 2, x minus 1, because we take away whatever h is, squared plus 4. That's how you convert, kids. Yeah. The goal was to write it in vertex form.
You still have to right.
2 minutes. You good, Trey?
Yeah.
All right, so we did 2 graphing, we did a conversion, and here is a write an equation in vertex form. And all you're told is some information about what lies on the graph, and I've got the steps off the side, and you can read them if you want. But what I'm going to do is I'm going to plug in what I know. I have this vertex here, -4, -2. What's that give me? It gives me h and it gives me k. So I'm going to plug in. Y would be a times x minus what? Minus a -4, right? It goes x minus h. And h was -4 squared plus, not plus, minus 2. It's plus a negative. So I can clean it up just a little bit. It ends up being x plus 4 squared minus 2. The goal here is to write an equation, and you almost have it. What's the only thing you're missing? Missing a. Go ahead, Sean. That's exactly right. That gives you an x and a y. Because, right now you have an equation with 1, 2, 3 unknowns. You can only have one unknown to figure it out. He said, there's that other point. It gives you an x and a y. So this y, I don't know why I can't talk in here. I'm never allowed to talk without 6 people talking at the same time. You notice that? Because I sure have. What can y become? What can x become? So 3 equals a times -1 plus 4 squared minus 2. That's something you can do, kids. So you do it. What's -1 plus 4? What's 3 squared? Where are you getting 7? I thought I heard a 7. And that 9's attached to a. You're not going to do 9 minus 2. That 9 is married to a. You're going to add 2. You're going to get a 5. What's a? You have to divide by 9. 5/9. And I don't know why the next part baffles kids, but it does. All you have to do is take this and throw it right there. An equation is written y equals 5/9 x plus 4 squared minus 2. X's and y's are in the equations you graph, kids. No, because equations have x's and y's in them. They have to stay there. If you just replace everything with numbers, you don't have any unknown variables. It's not an equation anymore. It's just numbers. So that's why it has to go back to here. You have to plug it in right there. All right, so that's done. So now we get to talk about what's called intercept form. Intercept form, it should actually be called x-intercept form, but it's not. It's just called intercept form. Talked about this yesterday. It is y equals a times x minus p times x minus q. And p and q are the x-intercepts. Those are also called roots. They are the roots of the graph. Roots are the things that happen as soon as the seed makes contact with the soil, kids. We call these roots. They're called x-intercepts or roots, because that's where the bottom of the graph starts. So that's intercept form. It's also something that's factored, so call it factored form. So this form is going to tell you where you cross the x-axis. It is not going to tell you where the vertex is. Now that comes from an idea. Is the vertex smack dab in the middle of these roots?
Yes.
Yes, that's a big deal. The vertex is in the middle of the intercepts. Basically, how do you find the middle of two things? So x is p plus q over 2. That's all it is. B plus Q over 2. We can't do opposite B over 2A because these things aren't written in a form where you know what B is. A you know, but that's it. So we have to literally take PQ, add them together, and divide by 2. That gives us the X value in the middle. And if you have that, how do you find the Y coordinate? You plug X in. Nothing more. So we only have one actual example of this. We should probably have two. We only have the one. No, we're just graphing. Kids who are good at math are good at graphing. Kids who can't graph are not good at math. All right, so we're tasked with graphing twice x plus 3 times x minus 4. Now, by the way, I want to talk about the form up here. It goes x minus p, right? X minus q. And these things are in parentheses. I have said this, and I'll keep saying it all year long. If you leave parentheses, what happens to your sign? It changes. There's no ifs, ands, buts about that. We are supposed to plot our x-intercepts. What's one of them? One of them is where x is negative 3. That's what I heard Ty say. What's the other one? The other one is where x equals 4. All right? So there's an intercept. There's an intercept. Step 2, find the vertex. We have formula for that, don't we? P plus Q over 2. So that's negative 3 plus 4 over 2, I agree with. Positive 1 over 2. It's a fraction, big deal. Then we plug it back in. So we have 2 times a half plus 3 times a half minus 4. Just plugged in. I wouldn't expect you to be able to do that in your head. I don't feel like doing it either. 2 times 0.5 plus 3, which I don't know why I didn't say it's 3.5, but whatever, times 0.5 minus 4. Oh, wow.
That's a negative 5, not 0.5.
No, it is. That makes a whole lot more sense.
That's a big one right there, man.
Still kind of big. Negative 24.5.
That's not a little bit better.
I can't even plot that on my grid, can I? Nah, it's not a huge deal. It's just off the grid. So the x value was a half. Go ahead and draw my line of symmetry there because that's where the vertex lies. And the y value is somewhere down here. Do you agree? It's just somewhere down there. Ty is already over here talking about range, and he's right. He said negative 24.5 to infinity. Do you guys agree with that?
Yeah.
Bracket on that negative 24.5. Dylan, let's see if you've learned anything or listened at all. What's the domain? All parabolas have that as a domain.
It's gonna blow up on you, kid.
All parabolas. Spencer, what's the domain of all the parabolas you're ever going to talk about here? Yes, every last one of them that you ever talked about in Algebra 2. I did.
Yeah. I can do that.
All right, last problem. This is just on here again to make sure you guys get concepts like this. This is what we did in your homework. The height of a model rocket is modeled by the equation h of x equals negative 16x squared plus 256x plus 45. So this is given to you. How high is the rocket's platform? Anybody know just by looking at the equation? How'd you figure out it was 45?
Because that's your
So,
Hush, smart person's talking. How'd you figure out it was 45?
Because when x is 0, that's your y-intercept.
There we go. She figured this was the y-intercept. It happens when x equals 0. And again, if these pieces are 0, what's left? 45 feet. After how many seconds will the rocket be at its maximum height? Where's that happen at? The vertex. And it is at the x value or the y value. Y is height. This isn't asking about height.
So it's a negative b over 2a, right?
Yes, that's right. But I'm asking, do I find the x value or the y value? Look at question B.
oh, seconds. So
X, where x is the number of seconds. So we just plug some stuff in. What's B? So negative 256. Sitting over twice a negative 16. If you're using tech, double wrap. In fact, whatever you guys do after this school is out, double wrap, please.
What do you mean double wrap?
Double wrap. Double wrap.
I always heard it's a bad idea.
Say,
Yep.
8 seconds.
8 seconds.
How long it takes for the rocket to reach its maximum height. You make yourself a little model rocket and see if you can get it to go to its maximum height for 8 seconds. It's up there, son. How do we figure out the maximum height?
Plug in 8 and then
Plug in 8, so negative 16 times 8 squared plus 256 times 8 plus 45. I don't know what that is off the top. 1,000 what?
1,000.
Okay, so the kids with the calculator is saying 1,069 feet. Pretty good for 8 seconds.
Yeah.
Then it falls to the earth.